Alright, we saw a couple of these in class last week where we've got a function inside of another function plus a product or something like that of the problem. But we're going to be looking at when there is something inside of another function, a nested function, a composition of functions. We're going to say that inside piece, that x squared plus 1, I'm going to call that my u. You can call it another constant, but it's just common for us to call it the u. If that's my u, I've got this piece replaced. Now I want to see if I can replace the other pieces, the 2x and the dx, but let's see what happens from the u if we take its differential du. The derivative would be 2x times the differential dx. And when we look back at the problem, I've got my 2x and my dx. It's all a product, so all of this stuff can be written in, I could write it like this if I wanted, x squared plus 1 times 2x dx. And then we can see that there's a piece and there's a piece. So when we rewrite the problem, it now looks like the antiderivative of the square root of u du, or the square root of u to the 1/2 du. Taking the antiderivative, add 1 to the exponent, divide by that new exponent, so we get u to the 3/2 times 2/3 plus c. And the last thing that we want to do, don't leave your problem in terms of u. If you know that x squared plus 1 is equal to u, we can rewrite it as 2/3 times x squared plus 1 to the 3/2 power plus c. And we can always check it. If we derive it, the derivative here, drop the 3/2, 2/3 times 3/2 times x squared plus 1 to the 1/2 times the derivative of the inside, 2x. Sure enough, we end up right back where we started, so we know that we did find the correct antiderivative. Do one other one here before we let you get into practice your own. When you look at x squared plus 1 to the 5th power times x dx, you notice that there is a inside part to the function, that x squared plus 1 once again. We're going to set that as our u. U is equal to x squared plus 1. And as soon as I pick that is my u, I'm going to derive it and I'm going to find its differential du. Derivative will be 2x dx. But when I look back at the problem, I only have an x dx. I don't have anything about that 2. Well, there's nothing saying that I can't take that 2 and multiply both sides by 1/2. So 1/2 du is equal to x dx. So now when it comes time to rewrite my antiderivative, all of that is going to be equal to the antiderivative of u to the 5th power, and that x dx gets replaced with 1/2 du. Now because this is all a product, that 1/2 is just a constant that's multiplying and it's along for the ride, we can throw it all the way to the outside. Yep. And that's going to be a u. So 1/2 times the antiderivative of u to the 5th du, which is now something that we can integrate. The antiderivative is going to be u to the 6th divided by 6. Now, don't forget about my 1/2 plus c, or 1/12 u to the 6th plus c. And last step, replace the u. So 1/12 times x squared plus 1 to the 6th power plus c. Once again, if you want to derive it, you can check and see if you got the exact same thing that you started with inside the intervals to begin with. Alright, so your your task now is to go ahead and you're going to work through the other groups of integrals. I'll have answer explanations for each one of them, so give yourself a chance to work them through. When everyone's ready, go ahead and hit play on each of the clips of working through the other problems.